C'est parti.
Okay, so hello everybody. Thank you to be there for the first GDG event for the year. Welcome to the newcomers. I can see some new people. I don't know, so it's cool. Um, First, I recall what the GDG is. GDG Sophia-Antipolis is some events every month, either online or in person. We try to make some in-person event from time to time to meet for Rio. And the goal of this event is to present technical aspects of our life of developer. Um, I'm gonna start by present myself. I'm Fabrice Fontenoy. I'm software developer and also a Git trainer, and I'm co-organizer of the GDG with Donia, Amel, and Matt also, which I think she's very not there today. Um, I give the hand to Donia to present herself and to introduce Loubna also.
Hi everyone, I'm very pleased to be back in the game after a few months since the Dev Fest in November. I'm Donia, I'm a software developer for Isovalent, and I'm the co-organizer, as Fabrice said, of the GDG. I'm also having more tech events organizer stuff, especially for diversity and women in tech. I would love to connect with you if we are not. And today we are welcoming Loubna Bouzenzen, who is an amazing young girl. She's a 23-year-old aspiring professional completing her final year in the master program for big data. Seamlessly integrates her technical expertise in UI, UX, and UI design and Flutter development with a fiery passion for data science. Beyond her academic pursuits, Loubna is also a published author, so go buy her book, reflecting her commitment to sharing insights and fostering personal growth. Today, she's gonna present to us a very interesting and very deep topic about genetic algorithm and how you can use them, apply them to optimization problems. So she's gonna go step by step into the theoretical stuff to an example with the knapsack problem. I'm very curious about it. I never play with genetic algorithms, so Lubna, if you can connect, you're here, you can unmute yourself, and we're gonna just make sure we can hear you well.
Hello.
Hello,
Good.
we can hear you.
Can
Great.
you guys hear me?
Yes,
Yes.
So
that's
everything clear. Okay.
perfect. Do you want to share your slides so we're gonna check also?
Yeah. Is it clear?
Yes. Yeah. Good.
That's perfect. Good luck.
Thank you. So hello everyone. This is Loubna. I am big data student, and today I will be exploring with you the genetic algorithm from theory to practice. For this presentation, we'll start by introducing the field of optimization. Next, we'll try to understand what is genetic algorithm. And in the third section, we'll solve a knapsack problem using GI. And finally, we'll be exploring some application of the genetic algorithm in the tech world. So let's start with optimization. So we know by human nature, we are wired for problem solving. And today we seek more automated solutions for our real life problems. We know that these automated approaches rely mainly on algorithms, and there are many techniques for this. We have the numerical analysis, artificial intelligence, operational research, and of course, optimization. But what is it exactly, optimization? So we can say that optimization is derived from evolutionary algorithm and computational intelligence at first sight. But we define an optimization problem when our main goal is to maximize or minimize a function. Usually we maximize a profit, quality, or efficiency, and minimize a cost or a time. So this maximization and minimization problem are easily converted to each other. So as you can see, the minimum of a function is equivalent to the maximum of this minus this function, and vice versa. So we call this function the objective function, denoted as f of x, and the variable x is called the independent variable or the solution feature. We know that x is not necessarily one item. It can be a vector, it can be an array, it can be a list of lists, so it's different things. So this objective function serves as an evaluative measure to tell us if this x is a good solution or not. And we note that optimization involves about finding the optimum solution. We are not looking for a only solution, we are looking for the optimum one. And optimization can be applied in everyday life scenarios. So for example, you wake up at 6 a.m. because this is the optimum time for you. You don't wake up at 5 because it's too late, and you don't wake up at 7 because it's too early. So you are trying to optimize your wake up time. Next, we will talk about the optimization approaches. We have two categories actually. We have the exact method and the approximate method. So we start with exact methods. So exact methods aim to find globally optimal solution by exhaustively exploring the entire solution space. In other words, we try every solution in the resource space until we find the best one. Examples of some techniques in exact method, we have branching bound and linear programming, but exact method takes so much time. And that's why we have the second category, which is approximate methods. And in approximate methods, we have two approaches, the heuristic and meta-heuristic approaches. For heuristic approaches, mainly prioritize speed over guaranteed quality. As examples, we have greedy algorithm, hill climbing, and for the meta-heuristic approaches are higher level strategies. It's something in between. And as examples, we have simulated annealing and genetic algorithm. So as you can see, genetic algorithm is under the subcategory of meta-heuristic approaches, that is under the approximate methods of optimization approaches. So let's start with understanding genetic algorithm step by step. So what you have to know at first, genetic algorithms, earliest, most well-known and widely used evolutionary algorithms, they're very high effective for optimization. And of course, as the name suggests, that these algorithms are inspired from natural selection observed in our genes. Now I want to talk about the analogy of genetic algorithm. The analogy say, if you can present your solution to your problem as a bit of string, then genetic algorithm may solve it for you. What does it mean? That your solution can be presented as an array or as a list or as a list of lists. I will give you a very simple example. Let's consider, for example, maximizing a very simple function, as you can see. And here we have x1, x2, and x3 belongs to a certain research space. So our solution can be represented as an array, contains three elements, x1, x2, x3. And this array is called the chromosome, and each value is called a gene. Now I want to talk about preparing for implementation, because before applying genetic algorithms, there are two crucial decisions you have to make. Otherwise, your genetic algorithm may be bad, The first decision is to decide chromosome encoding. You may ask yourself, how do I want my solution to be presented? So you have to consider this type of encoding. You can encode your solution in binary or integer or real valued or permutation. So as you can see here, we have three examples. So this is an array of Boolean values. This is an array of integer values. And the third one is real valued encoding. The second important decision to make before the implementation is the fitness function. And a good answer for that is to ask yourself, how do I know if this is a good solution or a bad one? So you have three considerations to make. You have to define a fitness function that quantifies the quality of the solution. And the fitness function, if it is not carefully chosen, we may not reach the optimal solution, and it guides the algorithm toward this optimal solution. Next, we will be starting the algorithm process. So first and foremost, you have to create your individual representation. As we talked before, you have to create the representation of your individual. Then initialize a population. So you set a parameter called population number. And what you will do, you will create a population by randomly generating multiple individuals. We're gonna make many copies of our individuals, but with different values, of course. For example, we have this population of 4 individuals, but of course, in real life, we have a large number. And the third step is to create the fitness function. For example, if we consider our fitness function is the sum of items, then the next step will be determining the fitness function for the whole population. The fitness, for example, fitness of individual 1, we got a 3. For individual 2, equal 2, and etc. And the third step is to make genetic algorithm operations. We have 3 necessary operations for genetic algorithm. So until convergence or number of generation equal the maximum, we're gonna repeat these 3 operations. The first one is the selection operation. So after evaluating our fitness for entire population, we're gonna choose individual with the best score fitness. So there are many methods for this selection process. We have tournament selection, we have roulette wheel selection, or rank-based selection. All these methods are based on the highest fitness score. Then the second operation of the genetic algorithm is the crossover operation. Mainly, we're gonna mate individuals. So mainly, we create pair of parents from the selected individuals. And then we randomly choose a crossover point. So crossover point is this, for example, if we consider this array, this is a crossover point. Then starting from these 2 parents, we create 2 children. The child 1 contains the first part of parent 1 and second part of parent 2, and child 2 takes the opposite parts of child 1. So if the child give us higher fitness function, than the parents, we select the children, otherwise we keep the parents. The third operation is a mutation operation. So mutation involves making small random changes to individual genes. So we start by selecting a probability, and for each gene in the chromosome, we generate a random number between 0 and 1. If this number is inferior than this probability, then we mutate the gene, otherwise leave it unchanged. So one of the types of mutation is to mutate 2 genes in the individual. For example, here we mutated D and B, so B become D and D become B. So to sum up the genetic algorithm process. We have to initialize the population, then assign fitness function and calculate the fitness for all the population. Then we apply genetic algorithm operators, selection, crossover, mutation. Then we got a survivor selection if the number of iteration equal the maximum or we got already our best. So we return it, otherwise we make a loop over these operators. For further explanation, we'll try to solve the knapsack problem, which is a very famous optimization problem. So let's define, first of all, knapsack problem. I know that the scenario that I'm going to talk about is very common. For example, consider yourself the night before your exam. So you are faced with a couple of chapters to make, but you have limited time because your exam is tomorrow. So you have to make a decision to choose which chapters are most valuable so you can maximize your score or your exam score. So this is what his knapsack problem is about. So its definition rely on a set of items we call N. So each item have a profit and each item have a weight. And we have to put these items in a knapsack or in a bag. And of course, the knapsack have a capacity value, let's call it C. So our objective is to make a decision to select a subset of items such that the total profit of the selected items is maximized, but considering this condition that the total weight does not exceed the C. So we have here a type of constraint optimization. We have conditions to respect. We are not aiming to maximize or minimize, but also respect a condition which is don't exceed the weight. So let's start implementing our KP problem with GI using Python. So as I discussed before, the first decision is the individual representation. And for the knapsack, the most effective representation is the binary format. So we create an array consists of length of the number of items. So example, if we have 6 items, we create an array of 6. And 1 means indicate placing this item, and 0 means exclusion of this item. So I have 6 items. The first item is in the bag, the second item is not in the bag, the third item is in the bag, etc. The second thing, or the next step, is to create our item class. So we create a simple class called item that has, so each item has a name, value, and weight. And then we define our knapsack class. So a knapsack is defined by the items and their capacity. And then we create our fitness function, which is summing the total values of these items with respecting this condition that the total weight doesn't exceed the capacity of the knapsack. Then we set our select function that represent our selection operation. So for this, we used a tournament style selection. So this is mainly where individuals compete in groups of 2, like we make a tournament, we select individuals randomly by 2, and we kind of make a competition between them, who's gonna survive from them. So our tournament size is 2, and then the tournament is gonna generate random samples from our population, and then the selected parents is the maximum, the one who got the maximum of fitness score. The next step is defining the crossover functions. So for the crossover function, we have 2 parents as parameters. We create a random variable if this random variable is inferior than crossover rates that we have defined before. So we make a random crossover point and we return our children. Otherwise, we return the parents. And for our mutation function, it has as a parameter our individual. And we make a copy of this individual, then we generate again a random variable between 0 and 1. If it is less than this mutation rate, then we mutate our gene, so 1 becomes 0 and 0 become 1. I want to talk in this section about the genetic algorithm parameters. First of all, it is so crucial to define a good population size. More options means more chances to find the best one. Also, the number of generations. So more rounds mean more chances of improvement. And also we have the crossover rate and mutation rate. So the crossover rate, it is advised to be a high value. Mostly it is 0.8. And higher rates means more mixing and more exploring the research space. While mutation rate, it is advised to be low. Mainly we selected as 0.01. And the crossover rate and mutation rate in our case represent the analogy of exploration and exploitation in evolutionary algorithm. So evolutionary algorithms are intelligent because we have the exploration and exploitation. Exploration means we want new ideas, but exploitation means that we want to keep our ideas but make some small changes. And finally, I will finish up with some application of genetic algorithm in the tech world. So for this section, I want to say that genetic algorithm implied on many fields. We have, for example, natural language processing, and genetic algorithm can be used in feature selection, in text classification, model optimization, language model, hyperparameter, etc. So genetic algorithm is used inside the little details of the natural language processing process. Also, it can be used in image processing for optimizing image enhancement, feature selection, image segmentation, etc. And genetic algorithm also can be used in other fields like bioinformatics. And as an example, we have social science. So we can optimize survey designs, evolving social networks, structures, etc. So we came to an end for this presentation. You can find the detailed Medium article about GA in these two links and the full source code of the implementation I did with Knapsack in this link. And thank you so much for listening, for your patience. And if you have any questions, I'm here to answer. Thank you so much.
Congratulations. Thank you a lot. That was very interesting. And there are actually questions in the chat.
Yeah?
Yeah. Um,
Go on.
the first question is, how do you choose which selection mutation algorithm to select for a given problem? It's,
Can you repeat again?
yeah. So how do you choose which selection or mutation algorithm to select for a given problem? So basically, you have a given problem. How do you choose which mutation you're gonna do?
Well, this is the whole dilemma of genetic algorithms. So mutation selection and crossover depends on the problem we have. So there are many famous mutation functions for specific problems that they're famous, but if we encounter for a new problem, you have to think about it. It's an algorithmic thing. So it depends on the nature of the problem.
You wanted to say something, Fabrice?
Yes, about this question, what makes a mutation algorithm a good algorithm? Is it the fact that this algorithm will reduce the number of iteration, or what is there a criteria, a criterion for to select to say if an algorithm is better than another?
Is it a tutorial to make what? Sorry.
No, my question is how do you uh, do, do you know that an algorithm is better than another? Uh, what is the criterion to say it's better than another?
So how to say that a genetic algorithm is better than another one?
Yes, but more precisely about mutation algorithm that you will choose.
Okay.
Uh,
So
it's maybe it's not clear.
no, but what can I say for genetic algorithms specifically? As I said, you have to define your individual well and your fitness function well. If these are mal chosen, so your algorithm is not is from the beginning it's bad. You see, so this will help the algorithm more to converge, and mutation, crossover, and selection depends on the nature of the problem. So,
Okay.
okay.
Uh, Valentine has another question. Is there a way to twist genetic algorithm? Let us say my consumer do not want an optimal solution, but more like a set of good individuals divert from each other's, from which they want to pick the one they like. I'm not sure I understand the question, Valentin. If my understanding is correct, at the end of the run of GA, all my top individuals will be close to each other, right?
Okay, I can read the question. How do you choose which?
We are actually in the chat.
Yeah, I'm checking. Check already said a customer do not want an optimal solution, but more like. Yeah, so as we discussed before, if you want like good solutions, there are many techniques for optimization, you see. Like they prioritize speed over genetic algorithms. You can use other approaches like greedy algorithm, for example. It gives you good solution, but not mainly the optimum one, you see. I hope this is the question.
I guess yes. He said, thanks. Thank you, Valentin, for your very precise questions. Um, are there any other questions? Don't hesitate. If not, I think we can close up. Okay. Thank you a lot, Loubna,
Thank you.
for
Thank
your
you, Loubna.
participation, your
You're
presentation.
welcome. Thank
That
you for giving me this opportunity.
was great. And yeah, thank you, Alison. Very nice presentation. Thank you. Thank you a lot, everyone. See you soon for next talk.
Yeah.
And maybe in person, we'll see.
Yeah.
So don't forget to follow us on social media so you can actually don't miss anything. And you can follow Lubna on LinkedIn if you want to see her future evolution and content. She actually wrote 2 articles about the talk and genetic algorithm. Maybe we can share them quickly before leaving so people can actually grab it. So on her Medium, you can find 2 articles about it.
Yeah, also on GitHub, I have the source code of
Okay.
the implementation of NEPS.
So we will do a specific post on LinkedIn and Twitter with all the links so it will be easier for people to grab it. Okay. Thank you.
Thank you.
Bye.
Bye.